this video we're going to take a look at how to work with the function to find the equation of a tangent. So the first question here is find the coordinates of the point P at which the curve y is equal to h of x cuts the y-axis. So here is h of x, it's a function. In this case it's given the letter h instead of the letter f, just a new name. And it says where x is an element of R. That's nothing to be afraid of, nothing to throw you off. That simply tells us that the values of x that control this function can be real numbers. Okay? So finding the coordinate of the point where the graph cuts the y-axis. So anytime we go across the y-axis, there is something we know for an absolute fact. Whenever I go through the y-axis, whether it's a straight line graph or in this case a quadratic, so a quadratic that looks something like this, a rough sketch of it, anytime we cross the y-axis, there is a fact we know, and that's that the x-coordinate is 0, because the x-coordinate describes how far left or how far right you are from that axis. So whenever you see that appear in a question, that's something that you immediately know, that when you cut the y-axis, the x values are 0. Alright? So let's work with that then. So for part 1, what I know for a fact is that x is equal to 0, and we know that because we are cutting the y-axis. And when you cut the y-axis, I know I'm repeating myself, but hopefully you remember it, when you cut the y-axis, x is equal to 0. When you cut the x-axis, by the way, we know for a fact that the y-coordinate is equal to 0, because the y-coordinate describes how far up or down from the x-axis you have gone. So the next thing we have here is that x is equal to 0. We've got h of x is equal to this. So I'm going to do what we do with functions. So we've got our function h of x is just the name of it. And then instead of the letter x, we're filling in 0 here. So I replace x in each of these positions with 0. So we're going to get h of 0 is equal to 5 plus 3 by 0, take away 0 squared. Then we tidy that up. It'll be 5 plus 0 take away 0, which will give me just 5. Now, it said find the coordinates. So I haven't answered the question fully there. So to make sure that I've answered the question properly, I need to report my answer as coordinates. So the answer here is going to be in terms of x and y. So x goes first. The x coordinate is 0. The y coordinate is 5. Okay, the next piece then is finding the equation of the tangent to the curve y is equal to h of x at P. So what we have is to find the equation of a tangent. Now when you see that word tangent, you need to think in your mind line, because that's what a tangent is, it's a line. So actually what they're asking for in that part 2 is for us to find the equation of a line. Now, if you go to your log tables around page 18, you will see that the equation of the line formula is y minus y1 equals m into x minus x1. And what you will need to do to get the equation of the line is you need to have m, which hopefully you remember from your studies of coordinate geometry is the slope. So we need to know the slope of this tangent, and we also need to know x1, y1. So we also need to have a point that's on the tangent. So let's see, of that information that we need, what do we already have? Well, they give us very little in the question to begin with, other than just find the tangent, but we do actually already have this. We do actually already have a point that will be potentially on that tangent, and we do actually know how to get a slope. Okay, so what we're looking for is the point. How we know that is that it's at the point P, and we just figured out what the point P was. So this is what the point P was, and we actually already have that in this case. So we're going to have 0, 5 is our x1 and our y1. For our slope though, we're going to have to do a little bit of working out. So I might just divide the page up for a little second for myself, and I might just work on getting the slope over here. Okay, so I need to find the slope. We're in a calculus question. You should know and hopefully be able to recall that when you want to get the slope in a calculus question, that's what differentiation is for. So when you find the derivative, or dy dx, or in this case h prime of x, you are working out the slope of the tangent. So for the slope, what we'll need to do is we'll need to find h prime of x. That is the slope. That's why it was invented, that's why it's there, that's what it works out. H prime of x is the slope. So while it's a process and a procedure, as you'll see in the other revision videos, it's also got a purpose, and the purpose is that it finds the slope of the tangent, which is what we're trying to find, right? We're trying to find the slope of the tangent to the curve. Now, how do I get that? Well, let's recall first what h of x was. So let's go back up and get the original. It was 5 plus 3x minus x squared. So it's going to be 5 plus 3x minus x squared. H prime of x, which is the first derivative. We take our time. You remember your kind of chant. You will multiply down by the power and take one off the power. In this case, this first one doesn't have a power, so this is called a constant. And the rate of change of a constant, or the derivative of a constant, is 0. So this is gone. We don't have to write it. You can put in 0 if you like, but you don't have to. Plus 3x, well, that is actually 3x to the power of 1. There's a hidden one there. How do we deal with it? We're going to multiply down by the power, so we get 3x to the take one off the power, 0. Same thing's going to happen here. Multiply down by the power, so it'll be minus 2x to the power of, take one off the power, it'll be to the power of 1. We then need to tidy this up a little bit more, so that's 0. We don't have to write. I didn't have to write it there. I was just showing you what happens to the 5. In this case, please remember, you should know off by heart, x to the power of 0 is 1. So I'm going to replace that with 1, and then I'm going to have minus 2x. So then we have 3 multiplied by 1 is 3, take away 2x. That is the derivative, and that gives us the slope of the tangent to the curve. Now, when it comes to a quadratic, there is dozens of potential lines that touch that curve once, right? So there's the curve. You could have this tangent here. You could have this tangent here that touches it there. You could have a tangent over here. And why we get this formula in terms of x is because this is actually still a little mini function itself. It's still actually a function itself. And that function actually tells us that the slope of the tangent, well, it depends on where you are, what x coordinate you're at. So if I'm at this x coordinate here, on the x-axis there, so if x is 1, that'll be very different from this x coordinate over here. That slope will be very different. So this tells us that the slope of the tangent that we want to talk about depends on x still. It's still a function that depends on what the value of x is. So what do we know about x, where we're at? What tangent do we want to talk about in our question? And the question that we want to do, or the one that we want to work with, is 0, 5. We want to work with it when x is equal to 0. Okay? That's what I'm picking, and the reason why I'm picking that, again, just to go back up to the question, is it asked me to find the equation of the tangent to the curve at P. What did we know about P? Remember, it was 0, 5. X is 0. So we're going to now go and get the first derivative, so h prime of the function when x is 0. So it's going to be 3 minus 2 by 0, and if I tidy that up, I'm going to have 3 minus 2, which is just 1. Now, what does that give me? What have I done? Remember, the whole reason for working this out at all was I wanted to find the slope, and I wanted to find the slope of a tangent to the curve. When we got that, we got it as a function, because it's still, remember, you could have lots of different tangents. We wanted the one at x is 0. that's what we've got. So what this actually means, the h prime of 0, which is equal to 1, tells us that the slope of the tangent, so the slope of the tangent at x is equal to 0, we know it's 1. Okay, and that's what we wanted. That's what we took a pause and a little kind of, we divided our page up there to do little work to go and get that. So now I actually know the slope because we worked it out over here. So when they ask you to find the equation of a tangent, remember they're actually asking us to find the equation of a line. You get that formula from page 18 of your formula and tables book. You write that down. We use the FIFA method, formula, information, and then we're going to go and write down all of the information. So we've got m is 1, and now we're going to go and we're going to fill it in. So for filling it in, we go y minus y1 is this one, right? So y1 is 5, so y take away 5 is equal to m, which is actually the number 1, into x take away x number 1, which was 0. Tidying this up as best we can, we get y minus 5 is equal to 1 into x take away 1, or take away 0, and then we have y, sorry, I should have multiplied that out. Why did I just write it out again? Multiply it in. And I'm going to get 1x, and 1 multiplied by 0, 0, so I don't need to write that out. And then I'm going to have y equals 1x, add 5 to both sides, and I get y is equal to 1x plus 5. So that's the equation of the tangent there. So remember, key things, when they say equation of a tangent, you think equation of a line. That's on page 18 of your log tables. You could be asked, by the way, to find the equation of the line at least 3 different ways in the exam, if not more. You could be asked about it to find just the equation of the line looking at it. You could be asked to find the equation of the tangent to a curve, like we have here in calculus. And you could also be asked to find the equation of a tangent to a circle. 3 different ways you could be asked to find it, and it's the same thing over and over again. So I would consider this to be a key skill that you need to know, because if it could be asked in 3 different ways, then there's a high likelihood that it'll appear on the exam at least once.